Hello Math Analysis, this is section 5.4 and we're going to learn about trees today. So trees are everywhere around us and we're not talking about the ones outside. This is an example of the NHL playoffs. Go Blackhawks! Okay, here's another example of a tree diagram. We're going to use it to decide who we should buy, or not who, but what present we should buy somebody. So go ahead and take a look at these three questions and follow the tree diagram. Put the computer on pause, see if you get the right answer. All right, did you get these answers? Okay, so what exactly is a tree? So before I tell you what a tree is, we need to learn a new definition, and that definition is called cycle. So within a graph, if you can find a path that begins and ends at the same vertex and doesn't visit any of the other vertex twice, that's called a cycle or a circuit. So it doesn't say that it has to touch all of the vertices. Just pick a vertex and can you return back to that vertex while touching other vertices? If you can, then you have a cycle or a circuit in your graph. So take a look at this one. Can you find a cycle in this graph? Did you say ABC? Good job. Can you find a cycle in this graph? A little bit harder to find. Did you say F, G, H, L, F, G, H, L, K, and then back to F? And how about this graph? Do we have a cycle? And you'll notice in this graph we do not, because there's not a vertex here, so you can't turn around right here. And if you started at M and went to O and then to N and then to P, you would not be returning back to where you started. So this graph does not have a cycle. So what exactly is a tree? A tree is a connected graph that has no cycles. Okay, so do you think this is a tree? Yes, it's connected with no cycles. Do you think this is a tree? No, because it has cycle ABC. Do you think this is a tree? No, because DE is not a connected edge of the graph. Okay, so we're about to learn a new game called Clock Solitaire, and it will be a game that is on your quiz, so be sure you understand how it works. So the way Clock Solitaire works is you take your deck of cards and you make piles of 4, and you put them in the positions from 12 o'clock all the way back around with your 4 leftover cards in the middle. Notice that each position represents one of the cards in the deck. So up here at the 12 o'clock position, that's where our queens have their home base. At the 3 o'clock position, obviously the 3s have their home base. So all the numbers should make sense. All you have to pay attention to is that Jack is like 11, Queen is like 12, Ace obviously is 1, and then the King is its own pile in the middle. So this is how we start the game. We set it up with piles of 4 cards. Okay, so what we do after we have the piles of 4 cards is that we reach to the King pile and we flip over the first card. And whatever that card is, we're going to slide it at the bottom face side up of whatever card is showing. So let's say that you turn over a 3. I would slide it upside down under this pile. Then I would take the top card on this pile, let's say it's an 8. I would slide that upside down face up underneath this pile. And then we're going to turn over the card on top of the 8. Let's say it's a Queen. I would slide that face side up at the bottom of the pile. I would continue to play this game, and you'll note that if all 4 kings show up before you've turned over all the piles, you'll have lost the game. So this once again is explaining how to do that if you need to read that. So we can thank Donald Nuth for this. A couple interesting things he noted about Clock Solitaire is that you only have a 1 in 13 chance of winning, and that if you really want to know if you're going to win, we could tell before you play the game if we know what card is at the bottom of each of the 12 clock positions, not the kings. So how can we determine beforehand if we're going to win? Of course, it has to do with graphs. So here's an example of a game where they are showing you what card is at the bottom of the pile. So our job now, notice we did not turn over the king's pile, is to connect. We're going to draw a graph, so we're going to put the 12 vertices around. And, ooh, I did that wrong. Okay, so I'm going to correct that for the video, but I'm going to keep going. That should be a queen up there. We're going to connect the card where it belongs. So, for example, underneath the queen was a 5. So I draw an edge that connects the queen to the 5. Underneath the 9 was a 4, so I would draw a 9 and the 4 with an edge. Underneath the 6 was an 8, so I will connect 8 and 6 with an edge. So when you're done, you should get a graph that looks like this, and it's kind of hard to look at because all these edges are over on top of each other. So all they did was they redrew it. They looked for which vertex had the highest degree, which was 8, and they put him in the middle, and then they kind of expanded out from there. So notice that your graph has no cycles and it's connected. So this is a tree. And what we learned is if our graph is a tree, we will win the game. So you're going to try this right now. I'm going to have you set up a new game and flip all your piles upside down except the middle pile so you can see what card is at the bottom of the pile, and then you're going to create a graph and connect it. So that is this section, tonight's homework, and we are almost there. Math analysis, look at this. Hang in there, be strong. Take care.